Great, so next up we have 3 speakers before we get to lunch and the poster session at 12:30. First up we have Professor Feng here from UCSB CS department. He's also the CEO of Nubit, incredible. Next up we have Mark Logan from Misten Labs, and lastly before lunch we'll have Brandon Curtis from ID Lab. So enjoy.
Thank you. Good morning, everyone. My name is Feng. Today, I will be introducing Thunderbolt, a very interesting project that we have been building in the past years. First, brief introductions about the team behind Thunderbolt. So, our team is called Nubit. It was originally started by me and two of my other PhD students, who is also in the conference today. And our original research area was in the space of blockchain security and compiler, program language design, etc. Our initial mission was trying to bring all our expertise to the blockchain domain. And we started Nubit around 1.5 years ago, and we finished our 3 rounds of fundraising, and we raised about $12 million, which are led by some of the global recognizable ventures such as Polychain, OKX Venture, Spartan, etc. So what the problem we're trying to solve? So the problem we're trying to solve is very simple, right? For instance, today, if we have almost the whole morning topic about stablecoin, but so today, if you look at the market cap, the biggest market cap is still Bitcoin, right? Bitcoin is dominating the entire crypto markets. I think yesterday I checked, it was about 63%. So that's in terms of the market cap of Bitcoin. But on the other hand, if you look at the performance of Bitcoin as a network, which is also part of the Satoshi's original white paper, right? It can only have 7 TBS. What does 7 TBS mean? Meaning that within a second, it can only process 7 transactions. And how's that compared to, let's say, traditional bank system, right? Let's say Visa or Master networks. They can easily process over 20,000 transactions per second. So this is one side. And then, so on the other hand, so there's a lot of Bitcoin holders, for instance, around over 200 billion worth of Bitcoin are sitting on their cold wallet. And so what their Bitcoin holders, they want is that they want to get used. And they want to increase their capital efficiency. But they are hesitant of doing so because the moment they hand their Bitcoin, move their Bitcoin from their cold wallet to whatever network that is going to operate on, so you can think of they're kind of losing their original security, right? And so our mission is that how do we enable all this kind of scalability as well as programmability without sacrificing the original safety and security assumptions set up by the Satoshi paper in 2008. Okay, so here let me set up the goal, okay, and then I'm going to talk about how do we achieve that. So on the left-hand side, you can think of this as the performance of traditional Bitcoin network, right? In the sense that it's very slow, in the sense that for every transactions, it needs to at least 10 minutes to confirm a single block, okay? And so on the other hand, on Thunderbolt, we want to achieve almost instantaneously confirmations in terms of blocking time. And on the second aspect, so traditional Bitcoins, so you have very limited programmabilities. For instance, you have to leverage a Bitcoin script, which is tuning incomplete. What does tuning incomplete mean from a non-computer scientific perspective? You can think of in terms of the motions and expressiveness of Ethereum or Solana, those kind of tuning complete languages like adult, right? And so in terms of tuning completely like Bitcoin script, you can think of like a baby. It's like a newborn baby, okay? So which means that a lot of stuff, it's not like you cannot do it, just like it's going to be very tedious and tricky, okay? And finally, we also want to achieve high transaction without causing the user too much transaction fee, okay? So, and here's the side-by-side comparison. And if you just look at the feature and goal that we want to achieve, you realize that isn't this what the mainstream other blockchain trying to achieve, such as Solana, right? Solana is extremely fast, and such as Ethereum, right? Ethereum is fully programmable, and then you can build whatever DeFi protocol you want to build. And so, which means that if we just present those goals without constraint, this is similar to, let's say, I give you a car, let's say, at 2 a.m. on Highway 101, and everybody can drive. I believe that everybody can drive up to 150 or 150 or 200 miles per hour, right? All you need is just press the gas hard and hope for the best. And this is not what we originally designed, okay? So in order to achieve goal, we also want to achieve this goal under certain constraints, okay? So the first constraint you want to achieve is that, well, we want to be Bitcoin native, in the sense that whatever scalability or whatever programmability that we are going to introduce to this ecosystem, we don't make any additional assumption other than the basic primitive from Bitcoin, okay? Such as the tabular access data structure for maintaining the ledger, such as the default signature algorithm supported by Bitcoin, okay? So which means that with that sense, we cannot just naively launch a layer 2 and then move people's money from Bitcoin network to, let's say, whatever fork of Optimisms or Scrolls or ZK Sync they are, okay? So that's one design constraint that we want to achieve. And then the second design constraint is that, well, first we don't want to, because for a normal user, right, we want to keep things as simple as possible. So in that case, we don't want complex setup, in the sense that the user should not, like, let's say, prepare a whole bunch of liquidity by their own and worry about the route. And they also don't need to be online all the time and keep interactive. So which means that this also eliminate the options of leveraging Lightning Network, which is also currently the default payment channel for Bitcoin. And finally, because our team is coming from academia, we have been working on formal verifications for all kind of software artifact in the past decades. And we also want to make sure that whatever protocol that we design has to be not just certified by our team, not just certified by some random auditor, it has to be certified by mass, right? All of them should be machine checkable proof. So, which means that to do that, so before I introduce the solutions, let me just give some insight about the big ideas, okay? Before I talk about the 3 pillars, I just want to use a very simple analogy. So I know a guy who's called Raphael, who has been working with me during the past 5 years, okay? And all he did is very simple. He helped to clean my yacht once per month and charge for $40, okay? And I pay him through check, okay? And then after a while, I realized that Raphael is just his nickname. I don't even know his true name. And second, Raphael, he's not working alone. He actually have a gigantic team. For instance, every month I can see different people coming to my home and then help me to clean the yard. And then they get my check and pass to each other. Okay? So you can think of this as a pretty like similar to the idea that we want to achieve, in the sense that, well, first we want to make some transaction to exchange some services, right? But while we're making this transaction, we don't want to wait for the certification from Bank of America or Chase or whatever, right? So what we really want to do is that we want to have a way to transfer this kind of ownership, right? For instance, here between me and Raphael and his team, I'm using the check as an example to transfer this kind of ownership. So in here, in the context of Thunderball, you can think of, we can also achieve a similar ownership transfer through crypto signature aggregations without compromising user ownership, without compromising the privacy setup. Okay, and this is one thing is about ownership transfer, and then the second thing is about this kind of we need a committee to maintain this kind of a consensus, because the committee is going to help us to mitigate all those kind of a complex setup and providing liquidity that is originally required by the Lightning Network. Okay, and this you can think of. Sorry. So here you can think of this is also very similar to eventually, let's say one of Raphael's team, he received my check, right? At the end of the day, he needs to, some of their team member need to redeem and go to Bank of America to redeem the check and settle all the payment. But the thing is that, so the bank can actually verify the check deposit without requiring the check writer, i.e. me, to be present, right? So in this case, you can think of the committee is acting like what is a bank, the role of the bank that I mentioned in my example. And that here, the difference is that here the committee is not run by any authority, but it's run by a decentralized committee and run by BPFP, traditional consensus protocol algorithm. And finally, so because as I mentioned earlier, so we have to stay Bitcoin native, and then so whatever primitive that we are going to leverage has to be provided default by the Bitcoin network. So in this here, one of the key component and also weapon that we're leveraging is the Schnorr algorithm, and we leverage its linearity property to create a multi-party signature without sacrificing the trustfulness of the user. Okay, so now let's jump into the details. Okay, so before we jump into detail, let's first set up the actors and threat model. Okay, just like any other protocol. So in here we have user, we have Alice, Bob, and Carol, Zanny, etc. Some of them are sender, some of them are receiver, and then we make no assumptions about their integrity. Okay, and for instance, some of them might be bad guy. Okay, and we also have committee. Okay, and the committee is run by a whole bunch of nodes and users. In this case, so we also don't make any assumptions regarding committee as long as over less than F amount of their nodes are not being corrupted, then the entire network is going to be safe. Okay, and here the attack goal that we try to mitigate are two major aspects. One is we try to prevent double spending, and second, we try to avoid forging transaction in the sense that making ghost a transaction out of nowhere. Okay, and here is the high-level big picture of the workload of the protocol. Okay, and for more details, you can check our technical paper, which is a joint work with Dalia. And so you can think of the high-level pictures of the entire Thunderbolt protocol can be summarized using the figure at the bottom. Okay, so and in the bottom you can think of so we have the Bitcoin network. Okay, in the sense that assuming that Alice she has Bitcoin, which in the form of UTXO stored on the Bitcoin network. And what does Thunderbolt does? And this is also the questions I receive over and over again. It's not really a layer 2 per se. So what we are assuming is that there is an off-chain ledger. Okay, and of course you can use whatever ledger you can do. You can use Cosmos, you can use Ethereum, Solana, etc. But it doesn't matter. Okay, so our protocol is kind of chain agnostic. Okay, all we assume is just there is an off-chain ledger which act like the complementary data structure around Bitcoin. And then here, so there are 4 crucial steps about the Thunderbolt protocol. Okay, so the first, and I'm going to illustrate and on the details here, just give you the high-level idea. First, the preparing phase, you can think of the Alice first, in order to enjoy those kind of features of Bitcoin Thunderbolt, she first need to go process this kind of preparation phase so that she can move the access from Bitcoin to the Thunderbolt protocol. And at that moment, you might wonder, hey, isn't this the same as what layer 2 has been doing? And I'm going to explain the difference, okay? And once she moved the access, her Bitcoin to the Thunderbolt protocol, and then she can make all kind of transfer. For instance, she can transfer the access, the Bitcoin to Bob, and Bob can make further transfer to Carol, all the way to, let's say, the last guy called Zenny, okay? And for Jenny, so let's say he's done with the game, and then he wants to redeem. Okay, he wants to redeem, and all he needs is to run through the finalized phase, so that like all those transactions can be recalled down on the Bitcoin network. This is very similar to the Raphael example that I showed you in the previous slide, in the sense that throughout the entire collaboration phase, we don't need Bank of Americas involved, so they don't need to present until the last phase. Okay, and how do we achieve that? And so the original paper is actually quite technical heavy, and I promise that so this will be the last slide that is going to show any mathematical notation and Greek symbols. Okay, in the following, I'm going to illustrate the idea using terminology that can be understood by everyone. Okay, so the first phase is called preparation phase. Okay, so what is preparation phase? You can think of, let's say I have 1 Bitcoin in my safe at home, right? So I have the key, and then the key was stored on my own safe at home. But now this is not very good because I need to spend it. Okay, I need to go to Hawaii next month, so I need to spend it. So in that case, what I can do is that I need to move those Bitcoin or whatever financial access to the safe in the hotel, right? So the moment I move into the hotel, you can think of now, so the access is actually surely managed by both myself as well as the committee. In this case, will be the security team from the hotel. Okay. So, and the assumption is that nobody can actually access the access without a joint consensus between myself in here, this case Alice, together with the whole committee. Okay. And so in this case, you can think of so in terms of the technical term, so what this preparation phase and also called lockup phase does is that originally, so Alice holds certain amount of Bitcoin in UTXO, which is a default account model. Okay, and what she needs to do is that she select a certain amount of UTXO that she wishes to transfer, and then those UTXO is going to move to the joint safe managed by both Alice as well as the committee member who created a shared key. Okay, so now you can think of the original spending conditions. The original spending conditions of that particular UTXO was managed by the key from Alice. Now it's going to point to a location that is going to manage by both Alice key as well as the committee key to unlock. Okay. So in this case, even though Alice moved his access to a different location, but he still have the ownership to process those access. This is very, very different from traditional layer 2 that you might see, which is managed by the multi-signature by whatever founders they are. Okay, this is step 1. And step 2, so once you move your access to this kind of a joint safe, and then of course you can do the transfer. Okay, and this is the second phase called the transfer. And here, again, before I introduce the technical term, so the intuition of the transfer, you can think of, in addition to the original key, which is going to use to unlock my Bitcoin, I can add a sleeve on top of the key. Okay, and this sleeve was being added by, let's say, the recipient that I try to transfer to. Okay, for instance, let's say Alice right now she decide that she want to transfer this amount of money to Bob. Okay, and in this case, after they finish the transfer, and those transfer was not being done by the Bitcoin network, because the moment you want to do that on Bitcoin, you have to suffer the latency as well as the throughput of Bitcoin network. And what Bob does is that it's going to provide a sleeve, okay? And those sleeves only processed by Bob, okay? So which means that if you want to access the original key, you need to remove those kind of sleeves, okay? And in order to remove the sleeve, only Bob have the secret ingredient to remove that, okay? So you can think of this very simple, tiny adjustment that allow the transfer between Alice and Bob without like a very heavy consensus from the Bitcoin network. Okay, and in particular, you can think of so what happened at the protocol level is that, well, let's say first Alice, she wants to transfer her token to Bob, and she needs to adjust and modify the original key that is going to correspond to the access by adding a special leaf that only Bob can unlock, right? And this is step one. Step two is that and the committee is going to receive this kind of notifications, and the member is going to also adjust their original share key, right? Remember in the previous slide, so the committee first need to generate a share key to manage those kind of access, and because right now there is an additional layer, this kind of a tiny sleeve that is being added. So as a result, the committee also need to retweak the original share key. Okay, and once they tweak the share key, and the committee also needs to update the ownership. Okay, remember in the previous overview slide, so the core data structure of the Thunderbolt network is an off-chain ledger that is going to record those kind of off-chain transactions without compromising the security of Bitcoin, and this is where this kind of information is getting updated. For instance, originally the owner corresponds to Alice, now it's moved to Bob. Okay, and so here the assumption is that, well, nobody can actually open the original safe without a joint consensus between Bob as well as the community member. Okay, and as you can see, this very simple tweak actually allow a very almost instantaneously transform between users. Okay, and then they can repeat this over and over again as many times as they want, and all of them will be happens instantaneously. Okay, and so right now I'm going to directly jump to the last step. Okay, suppose right now I'm done with my vacations. Okay, I'm done with my vacations. I want to go home, and I want to redeem. Okay, I want to redeem, and so what you need to do is that, well, here at the hotel, what I need to do is that I just go ahead and then check out, and so that the security team or the committee member can provide a share key to unlock the safe box, and then I took out the access, and so everything will be settled. And this is pretty much similar to what the last phase of the protocol. Okay. In this case, let's say Bob, he wants to redeem. Okay. In this case, he wants to redeem in the sense of transfer this kind of joint ownership situation into a pure ownership on Bitcoin. And what he needs to do is that he just needs to walk to the attendants to show his the proof of his ownership in terms of the key to the sleeve. Okay. And then now the attendants can also provide their share key to work with Bob's key together, and now the locker actually recognizes both of them, and then it's going to release a Bitcoin, and then the Bitcoin is going to get settled on the Bitcoin network. Okay, this is very, very similar to the Raphael example in the sense that even in the last phase, while they don't want to transfer those kind of a check anymore, they can settle down on Bank of America, and this is also what's happening on the Thunderbolt network. Okay, so this is the high-level design of the Thunderbolt. As I mentioned earlier, because our team also work on security as well as formal verification for decades, and we also want to, and for such kind of a crucial protocol that is going to frequently dealing with financial access, we also want to make sure that it's actually fundamentally correct without any compromisations. So as a result, in addition to the protocol, and we also try to come up with a lot of crucial property that cover safety as well as the liveness of the protocol. For instance, safety properties such as ownership soundness, in the sense that only legitimate user can spend their funds, right? So if these funds would belong to Alice, it should never be spent by any other random people without occupying Alice's key. And then there's also a whole bunch of crucial liveness property. For instance, the ownership should transfer always. The transfer should always complete between those kind of participants if they are honest, right? And then there was also finality liveness. For instance, the user can always, under the worst case assumption, the user can also always withdraw their fund despite the presence of malicious user. Okay, and all those properties are being validated and verified through a formal verifier called tunneling proof. And this is also not just a tool or a prototype that live in the paper. This is actually a tool that is deployed on its mainnet. For instance, so this is this is not a real time. This is the video I took yesterday. So as you can see, right now we are actually doing this kind of whitelist campaign that allow people to participate and use the Thunderbolt network. And within less than 2 weeks, we already have around tens of thousands of users who's making quite a lot of transactions and the transaction, as you can see, the network is actually cover almost all over the world. Okay, and for those people, and so far they seems who use the network interact with our system, they seems to be unanimously happy. And so you don't need to read their testimonial one by one, but I think the biggest point they want to bring up is fast. Okay, so being fast also without compromising the security assumptions of Bitcoin. And okay, so to wrap up my talk, so I present the core protocol of the Thunderbolt network, and moving forward, as Christian mentioned, that there's a lot of ongoing effort we're trying to extend. For instance, we are extending our network to enable privacy features. Okay, this is extremely important, especially because for those people who has a lot of Bitcoin, privacy is actually their big concern, in the sense that they want to earn yields or they want to make transfer without revealing their identities. So in this case, we will also enable a privacy feature so that some of the transaction can be anonymized. And so we also, because we introduced this kind of a committee as a part of the crucial components on the Thunderbolt network, so which means that how do we make a robust economic mechanism to incentive to prevent them from doing something bad, or how do we encourage them to provide services? And that's also ongoing effort that we have been making. And finally will be the SDK as well as IDE and wallet support, so that we can enable Thunderbolt not just a self-contained network, but also make it connectable with other ecosystems. Okay. So the key takeaway is that 3 aspects. First, we want to dramatically improve Bitcoin user experience without compromising its original security assumptions. Okay, and then whatever we propose, we also certify through a mathematical proof, and we hope that what we start here can dramatically raise the imaginations of the entire Bitcoin ecosystem compared to just a financial access. Okay, and thank you for listening to talk. And then if you are interested, we are also running a campaign for the Thunderbolt network. If you are interested in participating in joining our network, you can also scan the QR code and provide feedback to our network and participate, etc. Thank you. I'm happy to take questions.
Really impressive work, and I love a lot of the choices you've made in designing this. Somewhat not a computer science question, but like part of the critical path here is really the go-to-market and building that community around the validator set. I'm going to call it that way, even if imprecise. Like, what are your thoughts on that? Because I think the Bitcoin ecosystem really needs something like this, and how you execute on that will be important, I think, for its
that's very important. So especially from a computer scientist who is not major in marketing, and that's actually one of the biggest challenges that I have been spending on. For instance, in the past 1.5 years, I would say majority of my effort was actually spending on marketing and community building as opposed to solving technical challenges. Yeah, I think that's very important. Yes, what we are trying to execute in here is that in order to make this entire community thrive, there are many aspects, like I showed in this figure, right? For instance, so the validator is one of the aspects. So what we're trying to optimize here is that we try to gain traction from users. Okay, we first try to let's make the committee and the validator side a little bit light, and also even like it's okay to make some trustful assumptions, like a single node or multiple nodes between trustful party, and then let's try to see under this kind of assumptions, and then what kind of the features that people really need in the network. Do they force everybody like faster, right? Everybody want to be fast, and everybody want to be almost zero gas fee. Okay, and also we're trying to exercise a little bit more features. And once we try converge into a relatively stable level, and then we will moving our focus to the validator. So right now the validator was mostly being done from between us and as well as our trusted partners and investors, etc.
Thank you.
Any other questions? Yes.
Can you talk a little bit about, you mentioned one of the slides that there could be some interesting opportunities for interop between this system and DeFi and other places and that kind of thing?
Oh yeah, that's a very good point. So you can think of if you know like what's happening in the Bitcoin ecosystem in the past 2 years is that everybody trying to push very aggressive, almost trying to move the entire empire from Ethereum and their as well as Solana to replicate them on Bitcoin, which I doubt it's a good strategy. Okay, so here you can think of what we're trying to establish at the first step is the payment. Okay, so let's first try to set up a very solid foundations on the payments. And this payment is not just for Bitcoin, because once you solve this kind of payment issues, you can connect the current protocol through, let's say, the PayFi from Solana. So here we are not trying to establish the payment ecosystem on our own. What we're trying to do is that we try to leverage this kind of a meta protocol so that we can easily and also safely collaborate with payment system from other ecosystem. And then so once we have a solid tractions on the payment side, the next step will be, let's say, I think one of the strongest requirement and demand from the Bitcoin ecosystem is get yields, right? How do you get yields? How do you safely get yields? So in this case, we can also foresee a lot of interconnected opportunity between whatever meta protocol that we build versus those restaking as well as the staking protocol that already established in like other ecosystems such as Solayers at Solana and Eigenlayers and Babylons, etc. Any other questions?
I think we are a little bit running out of time, so let's cut. Thank you.